My dear learners and mechanical engineering students, welcome to the 20th video for engineering thermodynamics course discussed about first unit of basic concept of thermodynamics, and this is the recap video part 2 consists of second part of the first unit recap corner. Okay, shall I move to the video? Now, in the last video, we have recapitulate about the various fundamental concepts and temperature measurement, heat and work energies, interactions and the conditions which we have kept, and sign conversions and types of systems, reversible and irreversible process, quasi-static process, importance and applications of zeroth law of thermodynamics, and this what is thermodynamic equilibrium, what are all the conditions required, was discussed in the last video. Let me continue in this video regarding first law of thermodynamics and its application. Okay, so now energy can neither be created nor destroyed, but only converted from one form to another form. This is a law of conservation of energy which you have studied from your schooling, is the form of first law of thermodynamics which could be applicable for a cyclic process. Okay, for any closed system taken through a cyclic process, the net work delivered to the surroundings is equal to the net heat taken from the surroundings, which is cyclic integral of del Q is equal to cyclic integral of del W. The energy of the system comprises of potential energy, kinetic energy, internal energy, and terms accounting for electricity, magnetism, and surface tension. Internal energy is a microscopic energy, that is the energy stored in the molecular motions. It is the energy stored in the molecular structure due to heat and the work interactions. The change in the energy of the system depends on the end stage and it is independent of the path of the process. It is a point function and it is an inexact differential. The exact differential, and thus the energy is a property of the system. Here you have to understand one more thing. Time is internal energy refers to the energy gained by the molecules because of either a work or heat interaction. Okay, if they are doing the work, means the energy of the molecules would be lesser, would become lesser, or it will start to reduce because of the energy utilization, or if it is getting the energy in terms of heat, means then the molecular energy would be raised. Okay, and if in an isolated system the energy of the system remains constant, consider if the non-flow energy equation for the first law, means then we could have del Q is equal to del W plus du. Okay, so del Q, del W and du have to be in consistent unit. Heat supplied to gas, work done by gas and increase in internal energy are taken as positive quantities, as I told. No, then heat received by the gas, work done on the gas and decrease in internal energy are taken in negative quantities. The perpetual motion machine of first kind is a hypothetical machine which produces continuous supply of work without extraction or absorption of any sort of energies from the surrounding. No machine can produce energy without corresponding expenditure of energy. As such, a perpetual motion machine of the first kind is impossible in practical application. The internal energy of a gas is a function of temperature only. This is called Joule's law, and for reversible process we can write change in internal energy, that is U2 minus U1 is equal to mCV T2 minus T1, that is mCV, specific heat at constant volume, into T2 minus T1, that is temperature difference. Enthalpy is a property of the system defined as the addition of or the summation of internal energy plus flow energy, PV. The useful correlations are helpful in the solution of problems is equal to CV is equal to du by dt at constant volume, and Cp is equal to dH by dt at constant pressure. Cp by Cv is also termed as gamma, and Cp minus Cv is equal to capital R, universal gas constant. Further, for polytropic process, PV power n equal to constant, and the another isentropic relation is concerned, T2 minus T1 is equal to P2 minus P1 the whole power n minus 1 by n is equal to V1 by V2 the whole power n minus 1. For a brief summary of non-flow expansion process, and refer to table A. Here already I have given that table in the video, that you please try to learn the formulas for various processes and their work outputs, heat transfers and change in internal energy was given in that table. Change in enthalpy and heat interactions are different quantities. For the solitary case of constant pressure, change in enthalpy equals the heat interaction, that is Q1 to 2 is equal to H2 minus H1 is also equal to mCp T2 minus T1. If it is du means mCv dt, if it is dH means mCp dt. H meant for internal energy along with the flow work, which is absent for closed system in U. Okay, the major characteristics of free expansion are that is unresisted, unrestrained or irreversible, and no work done takes place during the free expansion. Okay, and for isochoric process there is no work done, and for isobaric process the work done equation refers to P integration of dV. And isothermal process means you are getting P1 V1 ln of V2 by V1, and for adiabatic and polytropic process you have P1 V1 minus P2 V2 by gamma minus 1 or n minus 1. Okay, and then now let me move to the application of first law of thermodynamics, that is the mass flow rate. M dot is the quantity which passes a reference point per unit time. Its value is expressed in kilogram per second, that is M dot is equal to rho AV, which is also equal to AV by nu, where V is the flow velocity for steady flow, and no accumulation or diminution of matter with the machine means then the mass conservation equation would be applicable to all the steady flow equations. A flow process constitutes an open system through which the working fluid enters and leaves from the surface of the system. Flow work or flow energy refers to the work which a fluid does when it moves in or out of any passage. It represents the product of pressure and specific volume of the flowing fluid. And one more thing is the steady flow energy equation could be written on the basis of unit mass and as well as unit time. On the mass basis you can write that is all the three energies like m1 into h1 plus v1 squared by 2 plus z is at 1 plus q is equal to same energy out m into h2 plus v2 squared by 2 plus g is at 2 plus w. Yes, inside the that is throttling. Next, if we move to throttling, is the expansion of fluid from higher pressure to lower pressure. It is also called isenthalpy process. Isenthalpy means enthalpy remains constant in the throttling process, where we are not expecting any sort of work from the throttling process, and by keeping the enthalpy as constant, the pressure is reduced in the throttling process. The slope of the constant enthalpy line or a PT diagram at a particular state may have a positive or the zero or a negative value, which is called Joule-Thomson effect, which we would be studied in your fourth unit of thermodynamics. And unsteady flow manifests when the rates at which mass and energy enter the control volume and are not equal to the rates at which mass and energy move out of the control volume. So here I have not given the importance to unsteady flow processes, since the analysis are a little bit tougher. So you just try to know what is unsteady flow means. Mass will not remain constant, that is, law of conservation of mass cannot be applicable to unsteady flow processes, because with respect to time the flow properties would be keep on changing. The process of emptying and filling a vessel represents unsteady flow and taken as adiabatic. Okay. You first derive the SFE equation, that is general equation per unit mass and unit time basis. Try to learn it and then reduce. It is very much easy and easily followable when you are reducing the unwanted terms in the SFE equation, which is suitable to that particular thermal device on which the data have been given. Okay. Initially, immediately while starting the problem itself, you don't write that for boiler means only heat addition will be taken into account. For change on enthalpy and Q only I am considering, means if they have given any wanted data that any energy addition to be done, means you will be that might be a possibility of missing the data, and thus write the full form of the SFE always, and then try to reduce according to your need and wants and the given data in the problem. That is the effective way to complete the problem with the accurate answers and to evaluate the final requirement of the problem. Okay. And then another one more thing here, I have whatever the that is devices which I have taken of nozzles, diffuser, heat exchangers, and the turbine, turbine, and boiler, compressor, and all these and another one more thing is the combinations of these devices. All please you try to make use of this individually and as a combined manner. You just try to solve the problems. Okay. And then I hope that I have given enough and sufficient amount of inputs to you to get into the first unit of thermodynamics. Watch the videos again and again. If you don't understand, again you watch that video. It is not possible to understand this subject within a single time or two time watching. It is a little bit toughest topic. So keep on learning, watch the videos, happy learning, explore the things well. All the best, and I am signing off for first unit. Let me continue in the next unit. Thank you. Thanks for patient listening.